I am Dr. Praveen Chaurasia, working as an assistant professor, IMS Engineering College, Ghaziabad, in the Department of Electronics and Communication Engineering, which is affiliated to Dr. APJ Abdul Kalam Technical University, Lucknow. Today, I am talking about DIP operations and its fundamental steps. In previous one and second lecture, we have completed DIP, that is digital image processing, and how it is necessary for the processing purpose. That is important, that thing we have already covered in first and second lecture. Now, in third lecture, totally I am focusing about DIP operations and its steps of fundamental steps of DIP. Okay. So, let us talk about the digital image processing operations. So, here I am just giving 4 to 5 operations related to digital image processing, and these operations can be performed in digital image, by which we can identify better outcome of this digital image. So, if we talk about the first operation, that is actually the changing color space. So, how we can rectify red, green, blue color into the hue, saturation and some of the other terms, that thing we will talk about in changing color spaces. The second one is geometric transformation of images. How we can geometrically identify these images by using for the further processing purpose. Third one is the image thresholding. So, if we talk about image thresholding, then how much the amount is necessary for this particular image to identify, or we can say to extract information of that particular image. If we talk about another operation of this digital image, that is smoothing images, and that is also the very important aspect related to DIP operations. And if we talk about another term, that is morphological transformation. So, actually if we take the example of this morphological transformation, then you can also think about how you look after the 4 years, 5 years ago, or you can say in before, that information will provide the morphological transformation. So, if we go one to one for this one, that is the changing color spaces. So, if we talk about first term, then you can see here we have the RGB cube, and that cube is actually separated in 3 different blocks. So, related to this information, you can extract your information as a hue, as a saturation, as a intensity. So, these 3 terms you can observe related to these RGB cube. So, according to the changing color spaces operation, you can identify these 3 terms by which you can extract your desired information. So, here something you can also identify, that to change or convert the image spaces in an image from BGR or RGB to grayscale. So, that operation you can do by using changing color spaces. If we talk about another term, that is color space, is defined as all the possible tones generated by a color model. So, what will be the impact of color model? You can identify, you can directly identify through this changing color spaces. So, that operation is needed for this purpose only. After that, if you talk about the color model, is actually a set of equations, rules, which actually calculate the total complete color. So, we can say, if we summarize these 3 terms, intensity plus saturation plus hue, then you directly identify the complete RGB cube, and this is the vice versa process of this RGB model. So, that thing you can operate using changing color spaces. If we talk about another term, another operation of DIP, that is geometric transformation of images. So, if you want to tilt your image, or you can say if you want to extract information from the image by tilting, or we can say moving one kind of image, then your coordinate can be changed. So, as you can see here, this term is actually present on the 0 comma minus 2, and if you tilted this image, then it will be turn out to be 1 comma minus 1. So, that actually transform its coordinates. Okay. So, widely used for image registration and the removal of geometric distortion. So, if you move this information, this image, then some of the distortion you can remove from the image, that is totally undesired. And why, which kind of transformation we are performing here? That is spatial transformation, because here you are just changing its coordinate. See, minus 2 and 0 is changing up to minus 1 and minus 1. So, your image is actually rotated clockwise. So, we can say that operation is nothing but that is based on the spatial transformation, where coordinate system is very much important. Now, the common applications include construction of mosaics, geographical mapping, align images to correct images for distortion, and which kind of distortion? Lens distortion, or undesired, or so many undesired distortion you can remove by geometric transformation of images. Okay. Now, if we talk about another operation of digital image processing, that is thresholding. So, see, for the thresholding you can observe these two images. Now, here you can see this is the completely black, and this is the second one is completely gray. So, if we talk about and you are taking the negative of this image, then it will look like in this manner. Now, if you plot the histogram of this image, then you can say the complete portion, this second portion is completely black. So, it has the black identification, and that part is actually giving the idea of this white image. So, using the histogram you can identify the thresholding, and thresholding is nothing but by one kind of level. After that you can identify which part is black and which part is white. Okay. So, these actually the pixel value is more than, sometimes less than the threshold value, and otherwise it may be black. So, these kind of information you can identify using histogram graph, or using these kind of two images. This is A image and this is the second image. Okay. Now, if we talk about another operation, that is called image blurring or smoothing. So, here you can see this is the noisy image, completely noisy image. As an input you may observe. After that, applying the filtered operation, that is 5 cross 5 median filter, that thing we will also talk about later, and after applying this median filter you may observe this image into this term. So, your output is more clearly observable. After that, if you see another filter you apply on this input image, then it will look like in this manner. So, see, the image blurring operation is nothing but it is achieved by convolving the image with a low pass filter kernel, and it is useful for removing noise as same as the previous one, which is nothing but it is thresholding and geometric transformation of images. Okay. So, and it actually removes high frequency content, that is very important thing you may observe here. The high frequency content you may remove here, that is noise edges. Noise edges you can remove. See, on the edges part, that noise can be removed by this process. So, see, that is more noisy portion is there, and afterwards if you observe this thing, then it is completely black. So, you can say image blurred at that portion is completely removed by this operation. Okay. So, now if we talk about another kind of digital image processing operation, then you can say another kind of transformation, that is morphological transformation you may observe. Now, here you may observe, as I told you, the morphological transformation will tell you how you look like after the 4 years, after the 8 years, after the 10 years, after the many years. If you observe yourself, then you can also identify your image. So, see, if you have a complete image like this one, then after the masking it will look like this, after the dilation it will look like this, after the erosion it will look like this, and these mask, dilation, erosion, opening, closing, mg and th, that is threshold, these all are the parameters of getting the morphological transformation radiology. Okay. So, each and every part is giving important information about morphological transformation, and after completion of this entire process, you may predict your image, your complete image in different manner. So, in so many sites, in so many social sites, you may also observe you look like after the 4 years after, or you can say 10 years after, how you look like, then you can identify easily by using morphological transformation. So, that operation is needed for this purpose only. And if we talk about, that is very important topic of DIP. Now, if we talk about the fundamental steps of digital processing, that is actually the image processing. So, here if we talk about this thing, then first term it is very important, that is called image acquisition. After that, image enhancement is actually used, and what is the acquisition is actually required, then you can actually gather the information. After the gathering of that information, you actually identify that particular information after putting some enhancement on that particular image. Then some portion is missing, then that part has to be restored, so that you can identify the total image. After that, image analysis is needed, which part is important, which part is not that much important, and the second last, that is called image reconstruction. So, on the basis of all these 4 terms, that image reconstruction can be identified, and the last one, that is the image compression. Why it is so? Because image compression is actually save the bandwidth or save the size of image that actually required at the output end. So, that part it has to be included into the fundamental steps of digital image processing. Now, if we talk about one to one of these terms, so first of all, image acquisition. What it is? Image acquisition is actually doing by human eye, ordinary camera, X-ray machine, positron emission, tomography, infrared imaging, geophysical imaging. So, how you can capture the image, that actually tell about the image acquisition. So, these are the means by which you can identify, you can capture your image at first instant. Okay. So, if we talk about first term, that is image eye, then actually how image eye can identify the image formation, transduction and processing. These 3 process is present under the inside the human eye. So, if we talk about how image formation is actually working, so these are the part of eye by which image formation can be formed. Now, see, this is the complete diagram of human eye. Okay. So, cornea, sclera, pupil, iris, lens, retina and fovea. These complete phenomena, these complete part is actually responsible for your image formation. After that, image has been formed, then second portion is come to the picture, that is the transduction. and the transduction, these three term is actually important to if we understand the transduction part, that is the retina, rods and cones. And after the after the image formation and transduction process, the third part is coming into the picture, that is called the processing. How your image, how your picture is actually present, that part is actually the processing part. So, optic nerve of brain came to the picture to identify, to process the that captured image. Okay. So, that is the optic nerve that actually useful for processing purpose. Okay. And one more important thing I will also talk about here, that is called blind spot. What it is? The blind spot is nothing but it is a spot by which we cannot identify which kind of formation is there, because the fovea or lens and we can say other part, that is retina, sclera and fovea. These part is actually the responsible for image formation. So, image formation is actually present here and that portion is actually not included. So, at that particular portion you cannot identify which kind of image is there. So, that portion is known as blind spot. Okay. So, if we talk about image formation in human eye, then you can say if your image is look like this one, then complete image is actually moving downward. If it is look like, if it is actually present in this manner, then your image formation is just opposite. Okay. So, see in that portion it is actually opposite in nature. So, your image is actually recognizing in opposite manner. After that, if you see another kind of acquisition process. So, camera is one of the very important aspect by which you can identify the image acquisition. So, see that total completely phenomena of this camera can be worked as a image acquisition or sensing portion. So, see sensors are used to transform illumination energy into digital images, completely digital image you can identify using the camera. Sensors are, you can, if you talk about the sensor, then we have three different types of these sensors. First of all, that is the single imaging sensor, second one is line sensor and third one is array sensor. Okay. So, that phenomena is actually present in a camera. Energy, if you provide the energy, if you illuminate your camera into this energy, then this filter is working out, and after the power, if you provide the power on this portion, then you would have this voltage waveform output. So, that actually provide the digital image. After that, if we talk about another kind of sensor, that is single imaging sensor, then you can see that kind of phenomena is there, that linear motion is you may observe here, and to generate the two dimensional image, x and y direction between the sensor and the area to be imagined. After that, the film negative is mounted onto a drum. This is the film negative, and that drum is actually rolling from the x direction and towards the y direction, and by which the mechanical rotation you may have the complete image. And the single sensor is actually mounted on a lead screw that provides motion in the perpendicular direction. So, that is the actually working of single imaging sensor. If we talk about linear sensor, then such kind of phenomena is actually present. So, in a plane that kind of phenomena is there. In previous one drum we are using, but here a plane, a complete plane you have to use, and the sensor strip is moving actually with the linear motion. So, your image area is actually look like this manner. So, it consists of an inline arrangement of sensors in the form of sensor strip as we talk about here. the strip provides imaging elements in one complete direction and the motion perpendicular to the strip provides imaging in the other direction. Inline sensors are used routinely for airborne image applications. So, these are the applications you may observe related to linear sensor. After that, if you talk about another kind of sensor that is called array sensor, then you may observe this thing by using this diagram. So, see that is your element by which you are observing. So, illumination energy is this one. So, source is actually provide the energy here. After the reflection of this energy by using this object, imaging system is detecting this kind of image and by using imaging system that image is actually converted into this grid form and this grid form will generate an digital image and that image is actually generated after the sampling and quantization process. That thing we have already completed in previous lecture 1 and lecture 2. Okay. So, generally it is an digital camera. Response of the sensor is proportional to the integral of the light energy projected onto the surface of the sensor and it is actually useful for astronomical and other applications where low noise imaging is required more. So, these all three sensors you may observe related to the image acquisition and sensing. After that, if we talk about the theory of these three sensor and the operations of digital image processing. So, here we have covered first textbook that is Rafael C. Gonzalez and Richard E. Boortz and that is the textbook of this thing, this one and another book that is the Jairam Ramesh digital image processing we have also covered and if we talk about the color space advantages which is we have already covered the digital image processing operations then that book is very much important. So, that is the Marco A. Praise Since Narrow which is published on 2019. So, that thing we have covered and if you very much understand the relation of digital image processing operation and steps of fundamental steps of digital image processing, then you can always prefer for this edition that is the 2007 edition, third edition and afterwards if you do the practice of each and every operation and another term using the fundamental steps of digital image processing, then second book is very much important. So, that is all about the digital image processing operations and fundamental steps of digital image processing. Thank you.